Hello students, today is 31st December 2020. Everybody went through lot of struggles, confusion, particularly you students were highly worried about your board exams and studies. Now we are going to step into the new year 2021. Okay, let us hope that this year brings us joy, happiness, peace and prosperity. Let us be all positive. Yes, remember, so many disasters have taken place before, and this is something unimaginable scale. Yes, but this too will pass. This too shall pass. So with that hope, we will move ahead to the year 2021, and I am shooting this video hydrogen atom radius of the orbit as the last video of this year, and wish you all a very happy, prosperous new year. Yeah, let us begin our topic. See, in this video we will discuss about radius of the orbit of hydrogen atom based on Bohr's quantum theory. Now, why hydrogen atom is important, I will tell you, because it has a positive nucleus and it has only one electron revolving around it. It is simplest of the atoms. Okay, you will find that the positive nucleus, I will put it plus E, and there is an electron, positive and negative charge. Now the electron is revolving around the nucleus. According to Bohr's theory, it is in a permitted orbit and is revolving around it. Now this is consisting of a force called centripetal force, right? And that is a circular motion. So what is the centripetal force? Centripetal force, that is the force which is acting towards the center, that is Fc is equal to mv square upon r. Make it as equation number 1. Now what is making it keep it in this orbit? There is an attractive force acting towards the center, and that force is electrostatic force, Coulomb's electrostatic force. So we know that electrostatic force is given by the formula Fe is equal to 1 upon 4 pi epsilon naught into Q1 Q2. The two charges are E and E, right? E square upon R square. This is equation number 2. Now at equilibrium we compare these two equations, right? At equilibrium you will find that Fc is equal to Fe. Now let us put this in this place here, right? Fc, what is Fc? mv square upon r, which is equal to 1 upon 4 pi epsilon naught into E square upon R square. Okay, so let me cancel this one R and the another R. So what is the thing? My aim is to derive an equation for radius. So let me bring R is equal to 1 upon 4 pi epsilon naught into E square upon mv square. I brought it down. Now what is that thing we can change? E is a constant, m is a constant, all these are constant. V is going to be a variable, velocity, right? We can try to put it in some other term, let us say, avoiding the velocity. We know Bohr's quantization condition. What is Bohr's quantization condition? The linear angular momentum mvr is equal to nh upon 2 pi. Okay, now from this I can say V is equal to nh upon 2 pi into m into r. Yes, I got an equation for velocity. So now what I am going to do for convenience, I will find the velocity square is equal to. Let me make the square of this, because I have v square, I can directly substitute its value there. That is n square h square upon 4 pi square m square r square. Yes, it looks little complex. Do not worry. Mere substitution will cancel so many factors, right? So let me move on from here. I compared the centripetal force with the electrostatic force, and then I brought the Bohr's quantization condition. Yes. So now I have the equation R is equal to 1 upon 4 pi epsilon naught into E square upon mv square, which is equal to 1 upon 4 pi epsilon naught into E square upon m into, yes, m multiplied by v square. I am going to take this value, which is n square h square upon 4 pi square m square r square. Okay. So I have taken all these factors here. After this point, what I can do is simply I can try to cancel out the factors which are possible, right? So it is divided here. I cancel 4 and 4, and I cancel pi squared with the pi, right? And I can cancel m with the m square. So I have got here e square and divided by epsilon naught n square h square multiply by, right? And what is in the down here? It is here, we will take it up here. Okay, this is r. Okay, so this is r. So I got here 1 pi and I got m and I got r square. I got these factors with me, right? So I will cancel. I have taken it from the denominator, from the denominator's denominator to the numerator. So r square, r gets cancelled, right? So I have a formula here. R, let me keep the r here. R is equal to, let me cross multiply. N square, h square, epsilon naught divided by pi m e square. Pi m e square. So can I say r is equal to n square h square epsilon naught divided by pi m e square, and this is the formula for the radius of the orbit in the electron in the hydrogen atom. It's very simple. R is equal to n. What is n? Orbital number 1, 2, 3, 4. H, Planck's constant. Epsilon naught, permittivity into free space. Pi constant, mass of the electron. E, electronic charge. So we find from this R is proportional to n square. This is the important relationship we should remember. R is directly proportional to n square. That's one point. And also, if you substitute all the values, you will get that of the hydrogen atom. R naught is equal to 0.53 Armstrong unit, right? This is called Bohr's radius. That value R naught is called Bohr's radius. This is for hydrogen atom. You should remember very carefully, very clearly, we are obvious about it. We take hydrogen atom and discuss it, because hydrogen atom is the simplest atom, because it does not have a neutron. It has only an proton in the nucleus and an electron revolving around it. So taking this as the first step, we can develop the concept, and the hydrogen atom, we use this. And suppose you have some other atom, then everywhere you will bring a term called Z, because we know that for every element X, Z is the atomic number and A is the mass number. So Z can be brought into the system. But I will tell you, avoid that. It is not necessary, because when we are specific about a hydrogen atom, we can easily take Z is equal to 1 and the equation comes fit very well, and that is the way we approach it. Okay, I hope you understand the concept, and in the next video we will discuss about energy of the electron in the hydrogen atom. Thank you so much.